Good morning, students. We take some important questions from Haloalkanes and Haloarenes. That after the completion of Haloalkane and Haloarenes, we already started the alcohols, phenols and ethers. But we need to discuss some important conversions from the Haloalkanes and as well as Haloarenes. And from the textbook, question number 10.19, which I have mentioned here, there are 20 conversions based on the preparation and properties of the haloalkanes and haloarenes. If you remember all the methods of preparation, then you will be able to explain all the conversions. Actually, these conversions are absolutely and exclusively based on methods of preparation and chemical properties. So, see, if I give you first question, propene to propane 1-ol, like, so first to draw the structure of the propene. Actually, propene is triple 3 carbon CH3 CH double bond CH2. It's all right. And this is the propane 1-ol CH3 CH2OH. Sorry, CH3 CH2 and CH3. So what you do first? First you have to break the double bond by the addition reaction. If I react here with the help of HBr, then since we have to get all at one position, so we have to apply anti-Marconi-Cope rule. Because of negative part here, this bromide ion is the negative part here, goes to those doubly bonded carbon carrying more number of hydrogen. So it is called anti-Marconi-Cope rule or peroxide effect. Right, if we apply the Marconi-Cope rule, then bromine will go to the second point. But question requires that 1-ol. Therefore, we apply anti to Marconi-Cope rule, and here CH3 CH2 CH2Br, and then it is aqueous NaOH. Here the condition is the aqueous is very important because it is nucleophilic substitution reaction. Once you write the alcoholic KOH, then it is wrong answer because they need alpha beta elimination and alkene will be formed. But we need here, nucleophilic substitution reaction. This bromide and sodium, NaBr is out, and you are, got your answer, propane 1-ol. Very simple. Propene, addition of HBr, apply anti-Marconi-Cope rule, right? Then you add aqueous NaOH or KOH, you get propane 1-ol. If question will be like propane 2-ol, then bromine will be at the 2 position. There you apply Marconi-Cope rule. Right? Next is the ethanol to but1-ine. See, this is the formula of the ethanol, CH3 CH2OH, and this is the but1-ine, CH3 CH2 C triple bond CH. Right. So here first we need to change alcohol into halide. Otherwise there is no way out. When alcohol will be converted into the halide, you remember the methods of preparation. You take thionyl chloride, or you take PCl5, or you take HCl with anhydrous zinc chloride. Therefore it is easy to say PCl5, right, minus PuCl3 minus HCl. Then you get CH3, CH2 and Cl, ethyl chloride. Now one reagent is very important here, if you remember that reagent, that because we need to get the alkyne, so sodium ethanide or acetylide. So here you need Na C triple bond H, it is called sodium ethanide. So therefore we get, here is the minus NaCl is out, and but1-ine. 1, 2, 3, 4, but1-ine. Right, next is the 1 bromopropane, say 2 bromopropane. First to write the bromo at one position, CH2, 1 bromopropane, then you write here 2 bromopropane. So this is the alcoholic KOH, which is the alpha or it is the beta. Now here, because we need the alkene, minus KBr minus water. What is that? CH3 CH double bond CH2, which is the propene. Now you apply here Marconi-Cope rule. What is that rule? Negative part of the addendum goes to the, it is the negative part of the addendum, this is the bromide ion, goes to the doubly bonded carbon carrying less number of hydrogen. So remember in 11th class I have explained you Marconi-Cope, and even in this unit 1000 times I have explained you what is Marconi-Cope rule and anti-Marconi-Cope rule. So because you need the bromo at 2 point, so you apply the Marconi-Cope rule, CS3 CH Br, and that is what it is, the CS3. Very simple. So the way you can get, you see, this is the 2-bromopropane. Now in that case we again take toluene. Benzene contains methyl group, is the toluene CS3, and here you need benzyl alcohol. So here Cl2 in presence of ultraviolet rays, HCl, CH2Cl, aqueous NaOH. Then you get NaCl, which is the benzyl alcohol. Benzene undergo chlorination, FeCl3. Now benzene you have to get bromobenzene. So here you have to apply, see, first nitration or bromination reaction. So first of all here we apply, see, first you write the benzene here, and if you write the nitration, then nitrobenzene will be formed and it is the meta position, so that will be incorrect. So first you need bromination, keep in mind. So bromination, if you get the bromobenzene, it is ortho and para directing. 4 is the para position. Therefore you need here bromination in presence of FeBr3 minus HBr, and this is the, what is that? This is the bromobenzene, and this is the 1, 2, 3 and 4. So here further you get the nitration HNO3 with H2SO4. Water is lost here because HNO3 is going to break like this. If you remember the electrophilic substitution reaction, there I have explained you OH plus H, and that is the 1-bromo 4-nitrobenzene. So this question, this name is actually incorrect in the NCERT book. That must be corrected like 1-bromo 4-nitrobenzene, right? So because bromine gives priority than the nitrobenzene. So in NCERT it is somehow wrong. So therefore write 1-bromo 4-nitrobenzene. Can you amend it now? If it is possible, then you can go for. So the way you can get the different conversions like propene to propane-1-ol, ethanol to butadiene, 1-bromopropane to 2-bromopropane, like this. Toluene to benzyl alcohol, benzene to 4-bromo-nitrobenzene, or rather you can say 1-bromo 4-nitrobenzene. It's alright, dear students. Now may switch over to the another 6th question from NCERT is that, like, first you note down the question and then you try yourself. First you think how do you get the convergence. It is purely based on preparation as well as property. If you don't remember the methods of the preparation, then you will not be able to position, you will not be in a position to write the answer. Next question is ethanol to propane nitrile. This is ethanol to propane nitrile. Next is the 7th is the, you can see, aniline to chlorobenzene. Aniline to chlorobenzene. Aniline to chlorobenzene. 2-chlorobutane to 3,4-dimethylhexane. 2-chlorobutane to 3,4-dimethylhexane. Now next is the Next is the, you can see, ninth convergence is the 2-chloroputane, ninth is the aniline 2-chlorobenzene, ethanol to propane nitrile, and then ninth is the 2-chloroputane to benzene to 4-bromo-nitrobenzene, ethanol, aniline 2-chlorobenzene. It's all right. Sixth is the benzyl alcohol to, okay, see here, benzyl alcohol से 2-phenyl ethanoic acid. Actually, that is the sixth question was, see, first of all you write here, actually, sixth question is benzyl alcohol to 2-phenyl ethanoic acid. Benzyl alcohol to 2-phenyl ethanoic acid. So first to write the benzyl alcohol, it is the CH2OH, right? It is benzyl alcohol. Now it is changed into halide. Now minus POCl3 minus HCl, then it is called as benzyl chloride. If you remember, if you get the acid, then it must be converted into cyanide, KCN. KCl is out here, K and chlorine, then it forms benzyl cyanide like this. It is treated with 2 molecules of water in acidic medium. Ammonia is lost, and you will get here, you will get 2-phenyl, it is the 1 or it is the 2, 2-phenyl ethanoic acid. It is, the name is already written here, 2-phenyl, this is the 1 or this is the 2, 2-phenyl ethanoic acid. So if you get benzyl alcohol to 2-phenyl ethanoic acid, then you will get first halide, then cyanide, whenever hydrolyzed is in acidic medium. This point you have to remember, in acidic medium, then it get, you can say, acid. Now sixth question is done. Now seventh question is ethanol to propane 1-nitrile. Now can I rub this part here? Okay. Now next question is, next question is ethanol to, that is the question number, is the ethanol to propane nitrile. 7th question. It is the question number 7. Ethanol to propane nitrile. Further you go for the same way. It is the CH3, CH2OH, get PCl5, then CH3, CH2Cl. This is the ethyl chloride. And if you get the nitrile, that means cyanide. In common system, nitrile is cyanide. So therefore you get here KCN. So K and Cl is out here, and this is the CH3, CH2C triple bond N. So that is what actually ethyl cyanide. Actually in common system it is the ethyl cyanide. But dear students, in the IPAC nomenclature, you go for, it is the 1, 2 and 3. Therefore in question propane nitrile, right? Otherwise it is ethyl cyanide, RCN. Is it clear to you? So you can write here, it is the ethyl cyanide. Now question number 8 and 9 is the 2-chloroputane to 3,4-dimethyl. So aniline to get the chlorobenzene. Anybody tell me, aniline is the, what is that? Benzene contains NH2 is the aniline, or aminobenzene, phenylamine and benzenamine. There are 4 names. Any one name you can use, because when benzene is the mono substitution, then common name and IPAC name will remain. Same, either write aniline, it is the more popular than the phenylamine, aminobenzene or benzenamine. Is it clear? So first you get diazotization reaction. Whenever aniline is made to react with NaNO2 and dilute HCl at 0 degrees Celsius to 5 degrees Celsius, then this reaction is very common and very important, diazotization reaction. Di means though, azo means nitrogen. So it is called diazotization. It is in short, it is called as BDC, benzene diazonium chloride. Further, you can go for copper with HCl. This is the Gattermann reaction. If I take copper chloride with HCl, Sandmeyer reaction. So both are equally good. You can take here Gattermann reaction, which is the Gattermann. I have explained during the preparation of chlorobenzene or bromobenzene. There I took two reactions. One is the Sandmeyer, another is the Gattermann. Sandmeyer and Gattermann. First take BDC, then treatment with copper powder with HCl, Gattermann reaction, copper chloride, chlorobenzene is formed here. So it is the chlorobenzene and 2 gas is evolved. So now the next question is 2-chloro, which is the 2-chlorobutane. 2-chlorobutane say 3,4-dimethylhexane. So this is the 1, 2, 3 and 4. If I write here in that way like 1, 2, 3, 1, 2, 3 and I write here CS3 and Cl. Right. So one thing you remember it here, it is the 1, 2, 3, 4, 2-chlorobutane is alright, but you have to get hexane and 2 substitution. So 6 plus 2, 8 carbon. Which reaction is used to carry double hydrocarbon? Wurtz reaction. Wurtz, W-U-R-T-Z. Right? 2 molecules of the alkyl halides are made to react with sodium metal and triether to form higher hydrocarbon. So dear student, you remember the name reaction. So here you take 2 molecules. I write here sodium metal further, and the same reactant is to be written this side here, so that we apply the what reaction? Wurtz reaction, CH2 and CH3. The way in presence of what is that? Dry ether, then it forms what is lost here? What is lost? 2 NaCl. Right? 2 NaCl is lost. Then you take these 2 in one, CH, CS3, CH, CS3, CS2, and what is that? This is the 1, 2, 3, 4, 5 and 6. Either you can take 1, 2, 3 or you can take 1, 2, 3 because substitutions at the same point and longest chain getting 6 carbon hexane. So therefore 2, 3, this is the 3, 4, yes, 3 and 4 dichloro, 3 and 4 you say dimethyl, 3 and 4 dimethyl hexane, right? So you have applied the what reaction? Wurtz reactions. Now question number 10. Question number 10 is 2-methyl 1-propene, say 2-chloro 2-methyl propane. So further write down. Question number 10 is 2-methyl propane 2 Question number 10 is the 2-methyl 1-propene. 2-methyl 1-propene 2-chloro 2-methyl propane. 2-chloro 2-methyl, what is that? Propane. Now question number 11 is like ethyl chloride to propanoic acid. Ethyl chloride to propanoic acid. And question number 12, but1 into normal butyl iodide. But1 into normal butyl iodide. And question number 13 is 2 chloropropane to 1 propanol. 2 chloropropane to 1 propanol. And question number 14 is the isopropyl alcohol to iodophore. Isopropyl alcohol to iodophore. Dear students, here first we get, I have written the question and you can try yourself. Also 2-methyl propene. First to draw the structure. Propene means how many carbon? 1, 2 and 3 carbon. Therefore you write here, that is what it is, the 1, 2 and 3. 2-methyl and double bond. It is the correct structure of 2-methyl 1-propene. But you have to add here 2 chloro. Then you have to add HCl in presence of zinc chloride. So chlorine will be here. So this is what CS3, CH, Cl and CS3. 2 chloro and here 2 chloro, 2-methyl, you can see propane. Ethyl chloride, CS3, CH2Cl plus KCN minus KCl, CS3, CH2, C triple bond N. 2 times water. NH3, CS3, CS2, COOH. It is what actually propanoic acids. Whenever cyanide is hydrolyzed, acids are formed. Again, it is a repeated question. So but1 1, 2, 3 and 4. 1 is the double bond at the one point, CH, CS2 and CS3. But direct you cannot add the bromide because iodide, because iodide is highly unstable. There is possibility of the reversibility of the reaction. Size of the iodine is greater, so it is highly unstable halide. So you add first bromine. Since you have to add iodo, so first you get the bromine at one point and iodine at that 2 point. This is the anti-Marconi-Cope rule. CS3, CH2, CH2, CH2 and what is that? Br. Now in case of the NaI, which is the Finkelstein reaction. Finkelstein reaction. CS3, now CH2, CH2 and CH2 and ID. This is 1, 2, 3, 4, 1 iodobutane. So here we have applied which reaction? That is the Finkelstein reaction. It is the halide exchange method. Chloride and bromide can be replaced by the stronger nucleophile, that is the iodide, because iodide being the greater size. So it is out of all the halides, it is considered as the stronger nucleophile.